Let's look at the rotational kinematics problem. As you can see, the terms in these problems are very, very, very similar to what you would find in a standard linear kinematics problem. So the way to do these is to read the question a couple of times and then start making a list. We really don't need a picture because it's really hard to make an accurate picture of something just sitting in one spot spinning around. So let's see what we have. Well, we were told something was spinning at 216 revs per minute. That is an omega, and it's an initial omega. Omega 0, 216 revs per minute. Now remember, immediately we should convert it to radians per second, times 2 pi radians is in 1 rev, times 1 minute is 60 seconds. Now, these are the kind of things you want to look at the numbers you should get. For example, RPMs to radians per second. We want to make sure that we don't just blindly write down answers without thinking about them. 2 pi divided by 60 really is the conversion here. Well, that's about 1/10, because 2 pi is about 6. 6 divided by 60 is about 1/10. It's a little bit more. So if you get something too wildly over a tenth of 216, it's a mistake. And this conversion is 22.6 radians per second, which is within the ballpark. We were also told it's decelerating at 2.18 rads per second squared, so that's alpha is negative 2.18 radians per second squared. And we were given the time, 5.22 seconds. And we want to know through how many revolutions it turned. The number of revolutions is a delta theta. It is highly important you know the units of all the quantities discussed. I've been saying all semester, you have to know the units. If you know the units of a thing, you know the thing. Now you see why. Each of these rotational terms has a lot of different units. So here's what I do. I want delta theta, and I put revs under it to remind myself eventually I'm going to want revolutions. My equations will not give me revolutions because I'm solving everything in radian-based units. So what do we have? And again, you could even do what we normally do. What are the other two things we don't know? We don't know omega or omega bar. In this case, I don't need them. I can solve directly. I'll use delta theta, omega naught t, plus 1/2 alpha t squared. Delta theta, 22.6 radians per second, times t, 5.22 seconds, plus 1/2, negative 2.18 radians per second squared, 5.22 seconds squared. When you solve this, you get delta theta is 88.3 radians. And again, you see we're going to get radians out of it. Radians per second times second, right here, is radians. Radians per second squared times second squared is radians. This isn't the answer to the problem, because the question said revolutions. So we need to convert. Times 1 rev is 2 pi radians. Now, let's be very careful. If you do this in your calculator, you will get the wrong answer. If you do this, you will get the wrong answer. In fact, you'll get a number bigger than 88.3, which makes no sense. Why? Your calculator does not treat 2 pi as a number. Your calculator does this. 88.3 divided by 2 times pi. Order of operations will divide 88.3 by 2 and then multiply the answer by pi. You must put anything in the denominator in parentheses to make sure it multiplies them together. So make sure in your calculator you do this. 88.3 divided by parentheses 2 pi. That will ensure you get the proper answer, and when you do, you will end up with 14 revolutions. And again, the very quick check is 2 pi is about the number 6. 88.3 divided by 6 is about 14. So when you look at this, it makes sense. So look at the numbers before just writing down the answer. If you don't, you're going to make those big mistakes.